recording button. All right, so good evening, everyone. Welcome to the Global Math Department. My name is Lee Natero, and I'm not only going to be the host, but I'm also going to be the presenter this evening. We're going to be talking about Elevate Student Voices and What If Thinking with Desmos. Before we begin our session, I'd like to tell you a little bit more about the Global Math Department. The Global Math Department is an organization that is run entirely by volunteers. To keep the free, high-quality PD, we need webinar speakers, webinar hosts, and writers for our newsletter. Newsletter writers share about an area of math or math teaching that resonates with them or discusses recent math blogs that help teachers reflect on their practice. If you'd like to volunteer or know someone who would be great in any of these areas, please have them email us at globalmathdepartment@gmail.com or have them reach out to us on Twitter. So let's get started with tonight's webinar. Before I introduce myself, I'd like to explain how these webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. And if the chatter gets busy, I will do my best to catch the questions and address those at the end of the presentation. If you haven't already done so, please introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. All right, welcome Anna, and hello Sue, and Bonnie and Karen. And welcome, Lebo. I've got lots of people that I recognize in the list of participants today. So let me introduce myself here. My name is Lee Natero, and my career began in 1992, and I have taught in public schools, independent schools, and higher education. I currently teach at Moravian University in Bethlehem, Pennsylvania. 19 of those years of teaching included teaching high school statistics, including AP statistics, and I currently teach statistics, math for elementary educators, and math for business. I am a National Board Certified teacher, and I renewed my National Board certification in 2015. I use Desmos to help students play with math and make observations. I have led many one-day workshops and virtual webinars on Desmos and Desmos Activity Builder, both in person and obviously virtually for the webinars. I am a Desmos certified presenter. I enjoy sharing my ideas about teaching mathematics, and I have spoken at over 50 local, regional, and national conferences. My Twitter handle is mathteacher24, and I've written over 200 blog entries at my blog called Mathematical Musings by mathteacher24. The hyperlink that you see on your screen right now, the bit.ly/GMD links, that actually has some of my blog entries. I've also have a YouTube channel, youtube.com/mathteacher24, that I began in 2008, and it includes short math tech videos, including 42 one-minute videos called TI Inspire Quick Tips. So hopefully some of the resources I'm going to be sharing with you tonight, you will find to be helpful. So what we're going to be talking about in this session, first of all, is what it means to elevate student voices. We're going to have a little bit of a chat explosion discussion. I'm going to talk about why I love Desmos and what's so great about Desmos. If you aren't already a Desmos fan, hopefully you'll be a Desmos fan after the session's over today. I'm going to talk about how you can use a single calculator page. So this is not an activity builder session. This is about using the calculator to let students explore and ask what-if questions. And we're going to talk about how they can do that individually, in pairs and trios, how you can use the calculator page for a whole class discussion, and how the calculator can help with creativity. And we're going to have hopefully some time at the end for questions and answers. And if you haven't already heard me say this, the hyperlink that I just put in the chat there, that has lots of great resources that you'll want to reference after the session's over today. Let's see here. There we go. So here is the first question that we have that I want us to think about. And we're going to be doing this as a chat explosion. So I want you to think about the question, and we're going to focus first of all on question A. What does it mean to elevate student voices? I want you to think about the question and respond in the chat, but I do not want you to hit enter until I tell you to do so. This way, everybody has a chance to respond, and not just whoever is the fastest typist, and we only look at one answer. This is a way we can ensure more voices are heard by having a chat explosion. So right now, think about what does it mean to elevate student voices, and type it in the chat, but do not hit enter until I tell you to do so. This is a strategy that helps to promote equity because all students have time to think and time to respond. I do this in my virtual classes. Students can share in the public chat or the private chat if they're not willing to share with the entire class. So what does it mean to elevate student voices? All right, go ahead and hit enter, Joe, and we'll take a look at what people have to say. Hearing the ideas of students feeling comfortable sharing their ideas, giving all students a chance, making sure every student has a voice in class. Oh, I like Karen's idea, putting students thinking on par with teachers thinking, making space and time to hear student thoughts. Yeah, and that can be really, really hard. Somebody shared in the Q&A with me that the student voices should be heard more than mine. All right. So yeah, definitely true. To elevate student voices, we need to make sure that we're hearing from all of our students, and whether that's orally or through the use of technology. I also do a strategy called stand and talk. This is kind of a virtual version of this chat explosion. For stand and talk, this is a strategy that I learned about from Sarah Vanderwerf, who teaches in Minnesota. And she gives her students a prompt and tells them to go and stand and talk to one other person about that prompt. And so everybody in her class is talking, and they're more willing to share than when she debriefs that prompt. All right, so what about question B here? We'll do this one also as a chat explosion. So whose voices are less likely to be elevated? Whose students are whose voices are less likely to be elevated? Go ahead and type an answer to that in the chat, but wait a moment until I tell you to hit enter. Think about the students in your classroom. What characteristics do they have that make them less likely to be elevated? Okay, go ahead and hit enter on that. Students who are shy, the less confident students. Yeah, if they've been labeled as smart or fast in math or dumb in math, the dumb students, that when I say dumb, they've been labeled dumb, they are less willing to participate. ELL students, for sure. So how can we elevate all student voices and encourage what-if thinking? We're going to talk about how to do that with Desmos, but in order for us to understand what it means to encourage what-if thinking and elevate student voices with Desmos, I have two other questions for you. One is, what would you say is what-if thinking? And this one we won't do as a chat explosion just because I want to make sure we have enough time to do everything here. But in the chat, what would you say is what-if thinking? What is what-if thinking? If you have a response for that question, type it into the chat. I think of what-if thinking as being, what do you notice? What do you wonder? I often ask my students, what do you think would happen if we did this or that? And Desmos definitely allows us to do that sort of thing. So it's really interesting. I had done the first two questions as a chat explosion, and I asked people just to contribute their ideas to question A, and it seems like the thinking stopped. So we're going to do question B here as a chat explosion. So this one's for everyone as a chat explosion. Question B, how do you respond to a what if question? Your students say, what if? How do you respond? Take a moment to answer that. We'll do that one as a chat explosion. So type your response to how do you respond to a what if question? All right, go ahead and hit enter on the chat. How do you respond to a what if question? All right, I have somebody that shared something with me in the presenter chat. Yeah, so how do you respond to a what if question? It's perfectly okay to say, I don't know. All right, you might say, I am not really sure, but I think that's a great question. And we're going to take a look at that tomorrow. And maybe you really had planned on looking at that tomorrow. But even if you hadn't, the student will remember that you're going to take a look at that tomorrow. And often just turning the question around to them and saying, well, what do you think? I think it's important for students to recognize that we don't know all the answers, and that a lot of mathematics is asking those what if questions. So I do want to point out that all students can do what if thinking. And when what if thinking is valued, more student voices are elevated. We're going to talk about how we can do this in Desmos, both individually, in whole class discussion, in pairs, how we can encourage this what if thinking with some creativity. And we're also going to take a look at an interesting question, something called random rendezvous, an interesting question that we can explore with Desmos. And it's really important that we get those what if and why questions from our students. And if you're just joining us, there is a hyperlink at the bottom of every single slide here. I just posted that in the chat. Feel free to click on that. And many of the examples we're going to take a look at today, I would say, are probably more Algebra 2 pre-calculus topics, but you can also adapt these for 8th grade or Algebra 1 or even upper level classes. So if you're not familiar with Desmos, this is the Desmos philosophy. Desmos is on a mission to help every student learn math and love learning math. And I will say my students definitely persevere in problem solving when they are using Desmos. So Desmos doesn't care really, the calculator doesn't care what their math background is. It just works with the student where they are. Desmos wants to build a world where a student's access to the power and beauty of math doesn't depend on any aspect of their identity. And as you know, Desmos has free calculators. There's the online and app versions. There are classroom activities, the free activity builder, which is Desmos Classroom, that the teachers can use to create their own activities. And you might not be aware, but Desmos also has a grade 6 through 8 and Algebra 1 math curriculum. So let's actually take a look at how students could individually use a calculator page to do some exploration. So these first two calculator pages that I'm going to show you, one's on ellipses and one's on hyperbolas, are ones that I created for my daughter, Cassie. She was a senior at Baylor. She actually just graduated this past May. And she had to take Calc 3. And one of the topics in Calc 3 is conic sections and 3D surfaces. And in her high school math class, she had never studied ellipses or hyperbolas. So I created these two calculator pages for her. And I'm going to show you both of these pages. So here we have ellipse observations. And so notice there's some directions here on the side. Let me actually make this a little bit bigger so we can all see this a little bit better. So here are some questions that you could give to your students with this particular calculator page. Do the following items here and write some observations. So change the sliders to make the ellipse a circle. Like, how can we make this ellipse a circle? That's definitely not a circle. Maybe I need to change this one and see what happens. Well, that looks like a circle. How does that happen? And what's the radius of that circle? Or make A 5 and B 3. How tall is the ellipse and how wide is the ellipse? And then there's another question that if the ellipse is 4 units wide on the x-axis and 12 units tall on the y-axis, what would the values of A and B need to be? And it's really easy to make something like this and then share it with your students. Notice I'm logged in here. You can easily share this with your students. I'm just going to copy this right now, and I will put the link in the chat. So you can have an opportunity to play along with that. But I do want to point out also that this is in this document, the ellipse observations. So everything that we're going to be taking a look at during our session today, you'll be able to go and get those calculator pages. But this was one example of an individual calculator page. Now, I will say it would be nice if we could actually still see these x-intercepts and y-intercepts on our graph. And I don't have that right now. Now, I know that the point on the y-axis here is the point 0b, and the point below is the point 0 negative b. So let's see if we can actually plot those and have that show up here and stay with the graph. So that's how that could stay with the graph. Let's do the 0 negative b as well. And of course, we could change the color of these if we wanted to. But let's say that, you know, you didn't want to have these seen by your student. You still want them to see the points on the graph, but you don't necessarily want them to see the 0b and the 0 negative b over here. We could actually add a folder. And then I'm going to, so I just clicked on the plus sign up here and said add a folder. I'm going to slide these two items into this folder. Notice there's a little vertical line that is connecting these here, and then I'll close that. And so now those are hidden inside the folder. And you might say, what if the student opens the folder? Well, if you hit enter enough times, the folder is now down below on line, oh, what is that? Line 14. So they can't even see that anymore. But now they might have a better understanding of how A and B are related to, or at least how B is related to the y-intercept. We have something similar with the hyperbola here. Once again, the student can move these around, and actually they're encouraged to click on these one at a time and observe them one at a time. So these were the two screens that I gave my daughter. These were the two pages that I gave to my daughter so she could learn about ellipses and hyperbolas for herself just by playing around with Desmos. So this is an example of how you can use a Desmos calculator page with a whole class discussion. So that previous one, you might just post that hyperlink in your students, in your learning management system, or share it with your students in some way and have them make observations at the start of class, or maybe that's their homework assignment, just to play around with that for 5 or 10 minutes. But this particular example that I'm going to share with you was one that I did with my Algebra 2 students. And this was called Name That Function. And we're going to actually take a look at this page, and I'm going to have you experience this page just as my students experienced it. And I'm going to ask that you share your observations for this one in the chat in a moment. So this was Name That Function. So here are the directions for this for you as a teacher. So in the line under Can You Name the Function, you're going to enter an equation for the function. And you might want to click on these points to see what the points are. So we had done this in my Algebra 2 class. We had just finished a unit on linear functions. That's all they knew. And so I asked students, what do you think this equation might be? What do you think this equation might be? So right now in the chat, Tell me, what do you think this equation might be here, this graph? This blue graph with the orange points. Go ahead and type in the chat what you think that might be. And while I'm waiting for a response from all of you, I'm going to tell you what my students told me. Right? I had them work with a partner. This was just displayed in the front of the room, and I asked for somebody to share. Somebody said y equals 2x plus 1, and so I typed that in. And sure, it didn't match. That's okay. I wasn't expecting it to necessarily match on the first time. Yeah, they might have said x squared, right? If they thought it was a parabola, they thought it was curved, they might have said x squared, right? X squared, but it's not that either. And to be honest, they were a little stuck when I did this. And so, you know, clicking on these points was okay, but I actually went to the board and I actually made these as a table of values. I had my x's listed there as -1, 0, 1, 2, and I had my y's listed as 1/2, 1, 2, and 4. And once I had it listed that way, I think they saw the pattern a little bit better. They noticed that the y value was doubling. And I said, okay, well, what does it mean if we keep multiplying by 2 again and again and again and again? And I had them discuss it with their partner a little bit more. And then, of course, somebody came up with the ones that you've put in the chat of y equals 2 to the x, right? Y equals 2 to the x. In case you're wondering, how did I get this function to appear here? Once again, it was in this folder, right? So I had this set up ahead of time. And notice I've got this labeled as a function g of x, so that when I created my table here, that my table was referencing this g of x function, so that when I put, let's say, 3 in here, it's changing it within the table. Yeah, students can easily make tables and graphs. They have a hard time setting up the equation. That is definitely true. And, you know, this was an exploratory activity. This probably took us about 10 minutes to go through these 3 functions, but it was just something for them to get used to thinking about something that wasn't a line. Although it was really interesting when the students said this, the 2x plus 1, because they were thinking in terms of a y-intercept. And they did get the y-intercept, but they realized that it wasn't a constant rate of change, that it started off slow and then grew more quickly. All right, let's take a look at the second function here. Get rid of this one and take a look at the second function. I'm going to hide the first function, right? This is for you in the chat. What's our second function here? And I'll click on some of these points. Go ahead and tell me that function. Can you name that function? Name that function in the chat. What do we think that is? And this one was quite interesting. I had more than one answer for this. Can you think of the 2 different answers? Yes, Steve's got them both there. Yeah, some of my students said, noticed that the y values were getting cut in half, right? They were getting cut in half. And so they said y equals 0.5 to the x, right? They said that. It's easier to see this if it's a different color, right? So they said that. And then, of course, we had another student that said the other answer, right, which is y equals 2 to the negative x. And of course, this one is also the same. And so the fact that both of these are actually the same function, you know, we had a discussion about that. You know, how do we know that these are the same function? How do we know that 1/2 to the x is the same as 2 to the negative x? And we had a bit of a review of exponent properties. And it was great for the students to see that there was more than one way to write that. All right, and let's take a look at one last one here. Now, this one was kind of interesting. It's basically a vertical shift of the one that we saw before. But my students, actually, some of them said y to the negative, let's see, y equals -2 to the x. Let me show you what it was that some of my students thought that was. And I just typed in what they told me. I knew that this was going to produce something potentially interesting, but I wasn't sure what. All right. And notice, actually, I'm going to make this as a table here. So here's our table, x and f of x. And, you know, what's going on here? Like, that's interesting. That's not something that we were expecting, right? And so I asked my students, why is it going back and forth here? It's not connecting them. Why is it going back and forth like that? And this helped us to realize that with an exponential function, the base cannot be a negative number, right? The base has to be greater than 0. So just some really interesting things that we got just by 10 minutes of thinking about this as a whole class. So I did not give the students this page individually. We did this as an entire class with them talking about this in pairs and us having a class discussion. All right, here's a chance for you to play along. We're going to take a look at playing with logarithms, And so I'm going to show you how you can do this on Desmos, and I would encourage you to try this out for yourself. We're going to work through steps 1 through 5 in the chat. And like I said, if you want to try this out for yourself, you can. So what I want you to do right now, and I'm going to use values that you give me in the chat. I want you to pick 2 positive even integers. You're going to call the first number A and the second number R. So right now, write them down somewhere, 2 positive even integers. I would like somebody to share with me the integers that they picked in the chat. I'll use those for our demonstration. So the first 2 positive even integers that pop up in the chat, first one we're going to call A, the second one R. All right, positive even integers. Yeah, Karen, that's not even. Oh, Trisha. All right, Trisha, you can definitely use 2 and 8. I'm going to use what Stephanie gave us, 6 and 8, but we might change things to 2 and 8 in the future here with this. All right. All right, and I had somebody else, Michael Fabroni, A equals 2, R equals 6. Yes, all right, let's just use, I guess, 6 and 8, since that was what Stephanie gave, and that was the first one. So I'm going to go to a new Desmos calculator page for this. So I'm going to go to desmos.com, and I'm going to click on the graphing calculator. I'm going to use, this is called projector mode, but I also call it, I'm over 50 and I need this for my eyes mode. So we'll make that a little bit bigger here. So what we're going to do is we are going to create 2 functions, log base 2 of x and what was the other one here? Log base 2 of x and log base 4 of x. So we're going to have f of x equals, and where we find log with different bases is under here, under the keypad. Let's see. And can you see that? Yes. Okay. Under the keypad, under functions here, if we scroll down, we can see, what is it here? Log of A, log base A. I said we're going to do log base A, let's see, log base 2 of x. So we'll make that a 2 and then an x. And I'm not really interested in the graph here per se. I'm going to be creating a table, so I'm just going to turn off the graph for a moment. Our other function is going to be g of x. And this is going to be log base 4 of x. And I know there's another way you can do this with the keyboard shortcut, but I'm showing you where you'd find the functions in general. So hopefully you're playing along. And notice that you can actually save this. I'll save this when we're done. And I'm actually going to be then posting that in our document with all the different hyperlinks in it. All right. So now we're going to create a table in Desmos. And basically my students just had this list of 5 steps that they did, and they worked together with a partner for this. So our third step here is to create a table in Desmos, and we're going to label the columns x, f of x, and g of x. So the table is going to reference the functions that we've already created. Easiest way to get a table is to type the word table, but you could also get a table by coming up here and adding a table. All right. I need this to be x and f of x and g of x, so I'm just going to relabel my columns. All right, so we got x, f of x, and g of x. So in the column for x, we're going to enter our value of a. And Stephanie gave us 6, so I'm going to enter a 6 here. And once again, I'm going to turn these off. We don't really need the scatter plot. I'm interested in more of what's going on in the tables with the numbers here. And then in the next row, we're going to enter a times r. So 6 times 8. And in the row after that, we're going to enter 6 times 8 squared. And then 6 times 8 cubed, and so on. Let's do one more, 8 to the 4th. So my students did this with their own numbers, right? The numbers that they chose. And if you wanted to use 2 and 8, like Trish suggested, or if you wanted to use other ones, let's see, like, I don't know, maybe 2 and 6, you can do that. Whichever ones you want to use, that's fine. Karen said you can type log then underscore 2 to get the correct math notation as well. So hopefully you've had a chance to do that for yourself. And I would like you to see if you notice anything about what we have going on in those columns. And this one is maybe a little bit harder to see. All right, what's going on? Any observations about the relationship between the two columns? What's a question that students might ask, or what's an observation? The same decimal digits within a column. That's really interesting. That actually, I don't know if that happens. That would be a great question. Does that happen if instead of 6 and 8, we have 6 and 10 or 6 and 12? One is half the other. Yeah. And if students don't see that, I'm just going to point out, we can add another column here. We can add f of x divided by g of x, right? And see that that's always 2. That's always 2, right? And of course, then the question is, what if we use different numbers here? You know, what if we use, what was recommended? 6, let's see, let's change this from a 6 to a 2. Well, that's kind of interesting. Now we have some nice numbers here. You know, why do we have these nice numbers? And I say nice because we don't have those decimals that we had before. You know, so yeah, you can play with all sorts of things here. And of course, this leads to all sorts of what if questions. Like, what if r instead of being 2, what if r was 1/2? Okay, what if, well, of course, that's going to be undefined for that one. Let's see here. What if r is 1/2? Oop, that's not quite how I wanted to type that. I'll just call that one 1/4. And this would be 1/8 and 1/16. So just interesting things here going on with this table. So this leads to lots of what if questions. And I love what if questions because they aren't inherently right or wrong. What if you used a non-even number, but a pair that was a multiple of the other? Yeah, so like what if I used, let's say, 3 and 9 maybe? So 3 here. And 9. And by the way, there's an easier way to do this, which I'll demonstrate in a second. Okay. Right. That is still 2 because of our base here. We got a base log base 2 of x and log base 4 of x. You know, what if we change this to log base 2 of x and log base, let's say 8 of x? That's kind of interesting. Or what if it was log base 16 of x? That's kind of interesting as well. And notice I typed in the 3 and the 9 and the 81. We could have just called this A if we wanted to. Let me add another row here. A equals, let's say we went with 6 and R was 12, right? Down here, I could have just called this A and this A times R and this A times R squared and so on. So we can actually do that as well within the table. Oh, A times R to the 4th. Yeah, so taking a look at how geometric and linear sequences are related to each other for sure. And then, of course, you can play around with this and see what's going on. Well, I wasn't expecting that for, I see, it's just a circle, just a radius there. But, you know, we can play around with this as well and see when do we get nice numbers here, you know, in our table here. So lots of great what if questions that the students can have. So there's one where it's nice. Yeah, definitely you can use these for justifying some log laws. As a matter of fact, we did like work with a change of base formula just to kind of see what was going on with this. And we did some simplification with that and that sort of thing. So lots of things that you can do and play around with this. When I did this with my students, they had learned about what a logarithm was, how a logarithm is related to an exponent, that logarithmic functions are inverses of exponential functions. But we hadn't done anything else with that. But there's a lot of things that you can do with exploring logarithms in this way. All right. So I'm going to kind of go back a little bit, maybe think a little bit more like algebra 1. You could definitely do this in algebra 1 with just linear functions. Or you could scale this up to pre-calculus and work with different types of functions. But this was what I called playing with patterns. And what I did is I had students work in pairs or trios, and each student was assigned one problem on the calculator page. So I had, I think, 10 different tables in there, and each student was, or each pair or trio was assigned one of the problems, and they were just supposed to click on the dot in front of that particular problem and explore that problem. So let me show you what that looks like. So for example, the group that did problem number 1, they had to click on the triangle beside their assigned problem and then click on the circle in front of Y1 to see their pattern. Here they had to possibly zoom. That's a zoom fit. So they can see all the points there. So basically each table was just assigned a problem from 1 through however many problems you have. This is just showing 1 through 3. And they were told just to click on their particular problem. But this is great because then as a class, when we debriefed these and I talked about their reasoning and how they figured out the equation for their pattern, I could just display this one calculator page in the front of my room as we had our discussion. So the interesting thing with this is that the students that worked in groups for this one noticed that the Y values were going down by 3. And so they said that they initially tried Y equals negative 3x. And then they realized that they couldn't see their function because it was off the screen. So they said, okay, we need to move this up. And so they might have played around with a little bit and said, let's add 5, and that's not enough. And let's add 10, and that's not enough. Oh, that was 15 there. Right. And eventually what they said is, you know what, we want this line to kind of go through the Y-axis, definitely above 20. And what they said was they kind of went backwards in the table. Rather than thinking about going down in the table and subtracting 3, they said, well, what if we went backwards in the table and added 3? And so they said we added 3 to 20 and got 23. That's how they figured out that the y-intercept there needed to be 23. So, you know, when I said, how did you figure out 23? She said, well, we just counted backwards. We went backwards in the table and pretended there was an additional row above that row of 1, 20. So this is something that I did with my students. And then we had a whole bunch of these to discuss. And this was actually to start thinking about arithmetic and geometric sequences. I mean, you could use it then, but you could use these types of things even within an Algebra 1 class when you're working with equations of lines. So that is playing with patterns. Let's see how we're doing good for time. Just checking. All right. So one of the things I also love about Desmos is that you can use a single calculator page to encourage creativity. So one year, one of my students created a pair of dice hanging from a rear view mirror. And it was only when I zoomed in to the picture that I realized he'd also drawn a car as an image in the rear view mirror. So students can get really, really creative with these things. There's also the Desmos art contest. The drafts that you see on the right, that was done by a student who won in the 13 to 14-year-old category. It was a worldwide art contest. This was a winner from not this past year, but the year before. But also I've done one where we have a virtual pumpkin carving contest. And I think maybe we need to do this in the future at Moravian, have a virtual pumpkin carving contest. And so here's how the virtual pumpkin works. So we have the blank pumpkin. All right, so this is the blank pumpkin. And you would give the students just the blank pumpkin, and then they can fill in the eyes and a smile and a nose. And if they want to add an image up above, they can. Of course, that looks kind of not so great with the grid lines on it. You can hide the axes if you wish. So there's the virtual pumpkin. This blank pumpkin was created by Adam Lavallee from Episcopal Academy in Newtown Square. And so I gave this template to my students when I taught at Moravian Academy, and we had a virtual pumpkin carving contest where the students had to submit this, and we voted on which one we liked the most. And that one won, I forget what the prize was. It was probably like a gift card to Dunkin' Donuts or something like that. But one thing I think you might find interesting is if you notice here, my nose is on line 21 and this don't eat all the candy is on line 23. That means that there is just one equation being used to make the nose. Just one equation being used to make the nose. And you say, well, how can that be? How can that be? If you think there's no way to create the nose with just one inequality, you would be absolutely wrong. Absolutely. If you're wondering what is that equation, here's the equation. You can see this absolute value equation. 1 is greater than or equal to y is greater than or equal to the absolute value of 4/3 x. And notice that I've restricted the domain, right? Without the domain restriction, it would look like this. I guess very similar, but I guess I had put the domain restriction there. All right. So lots of creativity can be done. Also, I just want to point out one other thing. Sometimes teachers say, hey, you know, I have to have math over the summer. My students I'm required by my district to have students do math over the summer. So I actually created a Desmos activity builder version of this where students can work their way through learning how to use the Desmos graphing calculator to create their art pieces. And so you could just give the students this hyperlink and that's their summer math. And they'll probably do more math with that than they would if you had given them a packet of worksheets to do. And they're going to be much more engaged with it and have a much more fun. And they will know if they're right or wrong based on how their graph turns out. All right, let's take a look at this last one that I wanted to share with you. Actually, I got that and a few other little things. This is something called Random Rendezvous. Two friends agree to meet for lunch. They agree to wait for 15 minutes for the other person to arrive. If they don't arrive in that 15-minute window, then they will leave. The friends arrive at a random time between noon and 1 p.m. The question is, what's the probability they will see each other? What's the probability that they will see each other? So right now, I just want you to put your guess in the chat. What do you think is the probability that they will see each other? Two friends agree to meet for lunch, and they agree to wait for 15 minutes for the other person to show. They arrive at a random time between noon and 1. What's the probability that you think they might see each other? All right, you got 25% chance, 50% chance. Unlikely to meet. Right? Definitely seems like it shouldn't be like high, like, 80% or 90%, because it's only a 15-minute window. All right. All right. So let's think about this a little bit. What are some things that we need to consider here? I want somebody in the chat right now to select a time for person A and then a time for person B. So give me two times. 12:43. So Stephanie has the one person showing up at 12:43, and Lewis says 12:10. So those are the two times they would not be meeting. But if the time Stephanie gave was like 12:14 and Lewis gave 12:10, they would be meeting, right? So that's the idea. And it's not really the 12 that matters, it's the minutes that matter. And so how could we organize these as a pair of times? Well, we've got person A and person B. We can think of that as an ordered pair. And then how could we visually represent these times? And we can represent these in Desmos, of course. So I have this set up here, and you can play around with this. Once again, these links for all of these different calculator pages that I've shown you are in this document. But here, I'm going to move this slider over to show some simulations here. So let's just do one or two. There's 1 point. Right? So person A arrived at 12:15, person B at 12:56. They're not going to see each other. Let's do another one here. Oh, a couple more times. Now this one, notice, is a different color. This one's black. Well, why is that black as opposed to these other ones being blue? Right? I think we can agree that the black one they met, where the blue ones they didn't. And of course, we want to do some noticing and wondering, right? What happens if we have more meeting times? All right, so this is showing 1,000 dots in here. And by the way, for students that can't see that, Desmos has this reverse contrast. Now, this is really bright in my opinion, but for some students, that actually makes it easier for them to see what's going on. And so you can kind of see here that the black points are kind of within the middle, and maybe it's about 50%. Maybe it's about 15%. Here's the region of successful lunch meeting times. And then, of course, what is the actual theoretical probability for this, right? The way I figured this out is I said the area of the entire rectangle here is 60 times 60, or 60 squared. And then I removed the area of these two triangles that we'd have going from 15 to 60 on the x-axis and 60 to 45 on the right. And then we have the triangle on the left as well. So we have two triangles. So for those of you that guessed 50%, you were pretty close. It was a little less than 50%. But of course, this leads to more what if and why questions, right? And any student can ask a why question or a what if question. So right now, I want you to ask either a why or a what if question in the chat. So what is a question that you might ask related to this scenario? Yeah, what if we change the 15-minute option, right? So some questions that you could ask is, what if we change that 15-minute option to a 10-minute option? What if we change it to a 20-minute option? Yeah, and the visual is really, really great here to think about this. And in case you're wondering, how did I get these points to show up here? I'm just going to briefly show this. I had some random number generation going on, but the points were different colors depending on if the absolute value of the difference was less than or equal to 15 or greater than 15. And so we could easily change this 15 to be 20 and play around with that and see what if. Yeah, what if we have more friends? What if instead of 2, it's 3? Now we're talking about 3 dimensions. And how do we represent that? So lots of other what if questions that we can think about. What if one person is willing to wait 10 minutes and the other person is willing to wait 20 minutes? Yeah, what if we change it to 2 hours instead of from noon to 1, it was noon to 2. So lots of great questions for students to think about. And once they start thinking about those and playing around with them, they'll play around with them for a longer time if they've created the questions themselves. So the last thing I'm going to share with you in about the last 3 or 4 minutes here is some questions that my students have asked me and how Desmos has helped me to answer those questions. So this first one is, would it be possible and why? Would it be possible for a graph to have both a sharp point and a smooth point? This was a question that was asked by some of my calculus students. Would it be possible to have something like that? And this is the graph my students came up with. They said, well, sharp points we usually associate with absolute value, and smooth points maybe with polynomial functions. And so this one is combining both of those. Pretty easy to graph that in Desmos. What about multiple sharp points? Can a graph have multiple sharp points? Well, here's a graph with multiple sharp points. And there's the function that created that graph. Now, of course, the students might be like, well, wait a minute. I thought, absolute value, you would always have to have the values above the x-axis here. Why is it that we have values above the x-axis and below the x-axis? And that would be a great question for them to explore. Maybe look at a table of values and think about what's going on with the outputs of each of the individual pieces here. This one is a great way to visualize why some equations involving square roots have an extraneous solution. I know in high school I learned, well, when you have this function, you need to make sure you substitute them both in, because sometimes you have to throw one out because it's called an extraneous solution. It's like, well, okay, that happens. Didn't happen all the time. Why does it happen? So in Desmos here, you can see I've entered the 2 pieces of this function. So y equals x minus 6 and y equals the square root of 18 minus 3x. The original equation was x minus 6 equals the square root of 18 minus 3x. So I just took the 2 pieces, the 2 sides of the equation, and set them both equal to y. And look what happens when we square both the x minus 6 and we square the square root piece. The x minus 6 part becomes a parabola, so the linear part becomes a parabola, and the part that was a square root becomes a line. And now we can see that we actually have 2 solutions. And one of those solutions was the solution to the original that we had back here, right? The 6, x equals 6. But we have a new solution that was created when we squared both sides. So this is showing what's actually happening and why we have an extraneous solution to the original equation. And then I think this is my last what if question that somebody asked me once. We didn't really talk about oblique asymptotes, but my students once asked me, so you can have vertical and horizontal asymptotes. Can you have slanty ones? That was the word they used. Can we have like slanty asymptotes? And so I created this particular graph for them to explore. And of course, one of the questions I might ask them is, how did I know that the slanty asymptote would be 4x plus 6? How did I know that? Where did that come from? So if you're interested in more resources for Desmos, you can visit the Desmos Help Center. And by the way, this entire presentation is hyperlinked within this document. And these items here are hyperlinked within the presentation. So you can visit the Desmos Help Center. Of course, you can email support@desmos.com. There's a great Desmos Educators Facebook group with lots of people supporting each other. And there's also the Desmos Classroom Activity webinars from the summer of 2022 on the Desmos YouTube channel. So that is all I have for this evening. It is about 5 minutes until the top of the hour. If you have any questions for me, feel free to type them in the chat. I'm going to see if there were any other questions that people might have had. And I'm going to just show you really quickly here again how easy it is to save. I'm going to save our logarithm exploration here. And I'm going to put this link in our shared document. I'll make sure that's an active hyperlink after our session's over. But blog entries, calculator pages on this resource. And if you didn't get that earlier, it's the bit.ly that you see here. I'll put that in the chat. I actually need to fix that link, I guess, because it's linking to an old one, but this one works correctly. Yeah, Desmos is a great resource. And to be honest, I only figured out how to use it by just saying, hey, let's see if this works. It's awesome for function notation and working with functions. All right, that is all for tonight, everyone. If you have any questions, feel free to reach out to me, linatero@gmail.com, or hit me up on Twitter. Good night, everyone.